All right, gang. Right now, what we want to focus on is VLANs. It's really critical that we're all on the same page when it comes to managing VLANs because this is how we isolate our network, right? This is how we keep everyone separate from each other. Remember, if you didn't have a VLAN configuration in your switch network, your network would have to look like this. Every time you needed to have a separate set of devices out there isolated from each other, you would need to actually configure them by plugging them into separate switches, and those switches would then need to be plugged into separate ports. And then by doing that, you could create these areas of isolation associated with each one of those networks, right? And that would be how you'd create that function. And then you'd have a 48 port switch with wasted ports. You'd have to utilize multiple ports on a router or use multiple routers. Not a good thing. I mean, it accomplishes the job, but it's not scalable. It's not extensible. It puts you, it makes you unlikely to subnet your network into areas to control the behavior of security and QoS and things of that nature. So, what do we want to do? We want to change this picture a little bit and make it look like this. All right. So down here, what we're seeing is a VLAN configuration in which our ports have been identified as belonging to the sales VLAN, the HR VLAN, or the engineering VLAN. How do we do that? Well, we assign those ports a VLAN ID number, like 10 or 20 or 30 or whatever we consistently assign on all of our switches to say, this is a set of devices that belong to each other. Everyone in 10, everyone in 20, everyone in 30. We give them labels for people like us to be able to make heads or tails out of them. And so that if there is off of that port somebody who belongs to, let's say, engineering, then we know we better go ahead and assign that a value of 30 so that he belongs to that VLAN, right? So it's per port, you assign access ports, VLAN ID numbers, and then all of these switches together kind of function like one big switch. I mean, really, if you just took multiple switches and connected them to each other and you didn't have VLANs, what would you have? You'd have one big network. What do we normally like to do? Not that configuration, but we like to have a hierarchical configuration so that everything is only, right? Everything's always a quick two-hop journey in order to get there, very consistent, no daisy chaining. And so we'll do the same thing here, only with this configuration, which recognize here's the base, the access layer, and then here's our distribution layer switch. What we've done is identified not only should they all function like one switch, but they should function like as many virtual switches as there are VLANs, so that they can all pass forward the traffic for 10, 20, and 30 respectively amongst each other. So how does that happen? Well, let me jump over to this slide because the key thing to remember is that there's two types of ports. You've got access ports, that's what's connected to our phones for voice VLANs or to our end user data devices, our computers and servers and laptops and everything else to carry our data traffic. And these will be assigned numbers. So we could have data VLAN with a number of 10. We could have voice VLAN with a number of 11. We could have a different data VLAN with a VLAN ID of 12. Now, the access ports themselves have those numbers, and then the switch makes sure not to allow traffic to be forwarded to any other port that has a different VLAN ID number. But what if this device in VLAN 10 wants to talk to this device in VLAN 10? How does the second switch know what VLAN the device is on from the first switch? This is the one and only place where the VLAN ID is revealed over the network, and that is over trunk ports. Trunk ports typically exist between our switches and sometimes between switches and routers. And we'll see again also that we may have a trunk port in a wireless LAN controller, all right, when we use a WLC. So it's in here that we will actually tag the individual frames with the VLAN ID so that the particular switch can say, I see what this belongs to, therefore I will only forward it if it's in the MAC address table that is associated with the same VLAN ID number. And if it is, then we're good to go. All right, so this is kind of just a quick review of VLAN behavior. This allows you to have multiple switches working together, coordinating their behavior. It means one switch with its various different ports that it has assigned to it can function like multiple switches that allow for, again, areas of isolation where there must be routing between them. And remember the key aspect, you must have a trunk port between your switches in order to convey this information, this VLAN ID set of tools that you put out there between your devices, between your switches, between switches and routers, that when you've got the router on a stick configuration, or to a layer 3 switch, or to a wireless LAN controller.